Hey everyone, good morning. I'm Pranshekhwar and welcome back to my YouTube channel. Now we are going to solve today's Leetcode daily challenge, which is number of subarrays with odd sum. Okay, so let's see what is this question and how we can solve it. So in this question, you are given an array of integers array. Return the number of subarrays with odd sum. Since the answer can be very large, you need to return by modulo it by this number. Okay, so what you have been given with an array and you need to find the subarrays whose sum is odd and you need to return that count. Okay, so the very basic or naive approach for this can be like finding all the subarrays of an array and calculating their sum and returning the count. So for taking out all the subarrays of an array, we can take up to big O of n cube complexity, or if we can optimize it, then we can do it in big O of n square complexity if we want to take out all the subarrays and do their sum. Okay, let me show the code like how we can do it in big O of n square complexity. Like we can start iterating on our array. Let's say 1 2 3 4 5 6. Right now we are at this point, and then we will do the sum of all these numbers one by one and then keep on adding, and then we'll check whether that sum is odd. If yes, then we will simply increment our count of odd subarrays, but this will take big O of n square complexity. And as you can see in the constraints that array of length can be 10 to the power 5, so its complexity will become up to 10 to the power 10, and which is going to give you the TLA. Okay, so this is for sure that we need to think of some optimized approach. Okay, so let's see what we can do. So you have been given with an array 1 2 3 4 5 6 and 7 as in this example. Okay, so what we need to do, we need to find the subarray sum, right? We need to find the subarray sum which is odd. Okay, so for finding the subarray sum, can we think of something related to prefix sum? Yes, why not? Okay, so let's see. So if you don't know about what is prefix sum, then don't worry, I will explain you. So prefix sum always starts with 0. Okay, initially our prefix sum is 0, and then we will add this 1 and then it will become 0, then this 1 will get added with this 2 and it will become 3, then this 3 will get added with this 3 and it will become 6, then it will become 10, 10 plus 5 15, 15 plus 6 21, 21 plus 7 28. So this is our prefix sum. Okay, so when we talk about prefix sum, so let's say if in the prefix sum, these are the indexes of the array. Okay, so if in the prefix sum you have been asked the sum of this subarray, so what you do, you will simply do the prefix sum of this index minus the prefix sum of this index, that is 15 minus 1 14. So you will simply get the prefix sum of this subarray with the help of the prefix sum. Okay, so with the help of prefix sum we can find the sum of a subarray. Now we don't know this thing, and we need to find the sum of a subarray whose sum is odd, right? Okay, so let's say a minus b, and we need a number which is odd. Okay, what is a? Let's say in the previous case a was 15 and b was 1. Okay, and we need something which is odd. So what we can do, let's say if our a is even, then what we can subtract from this to get an odd number? Let's say if we have 10, can we subtract 2 to get an odd number? No. Can we subtract 3 to get an odd number? Yes. It means if a number is even, then we need to subtract some odd number from this to get an odd number. Okay, let's say if a number is odd, then what we need to subtract? Let's say we have 7. Can we subtract 1? 7 minus 1, 6. No. Can we subtract 2? 7 minus 2, 5. Yes. So it means if a number is odd, then we need to subtract an even number from it to get an odd number. Okay, so we have derived a lot of things from here. So let's say while iterating on our prefix sum array, if the prefix sum is even, then we need to search for all the odd sums which has occurred before it. Let's say this is our even prefix sum, then we have to search for all the odd prefix sum which has occurred before this 6. Okay, but if we will go on for all the sums before this, then we will again doing an iteration. No, we will not do it. What we will do, we will simply keep two variables, let's say even sum count and odd sum count, which will keep the track of my even sum and odd sum before a particular prefix sum. Okay, so let's say when we reach this point, then the number of subarrays whose sum is even was only 1, because as this was 0, and the number of subarrays whose sum was odd was 2. Okay, so when we reach this array, when we reach this prefix sum, so we need to do check how many subarrays with odd sum has already occurred. So it was 2, so we will simply add 2 in our result. Why? Because see, here are two subarrays whose sum is odd. Which are they? This is 2, 3 and only 3, right? Okay, and similarly, if we will get some odd prefix sum, then we will check for all the even prefix sums occurred before this, and we will simply add that in our result. Okay, so let's say I run this approach once. Okay, so let's start from this prefix sum. This initially we will initialize our even sum count with 1 and odd sum count with 0, because the prefix sum is initialized with 0, so our even sum count will always be 1 in the starting. Okay, so let's start iterating on this prefix sum. Initially our prefix sum is 1. Okay, so it is an odd number. Okay, how many even sum count has occurred before this? Only 1. So what we will do, we will simply add 1 in our array, and as it is an even prefix sum, so we will odd prefix sum, so we will simply increment our odd sum count. Okay, now we are at 3. Okay, so it is also an odd, so we don't need to look for even prefix sum, which are 1, so we will simply add 1 and increment odd sum count. Okay, now we are at 6. This is an even, and we need to do a lookup for odd sum count, which is 2, so we will simply add 2 and increment our even sum count by 1. Okay, and now we are at 10, which is an even sum. Now we need to do a lookup for odd sum, which is 2. We will simply add 2 and increment even sum count by 1. Okay, now we are at 15. It is an odd sum. Now we need to do a lookup for even sum, which is 3, and we will simply increment our odd sum count. Now 21 is also odd. We will add even sum count in our answer and increment this by 1. Now this is even. We will add odd sum count in our answer and increment it by 1. Okay, now let's add them. 1, 4, 6, 7, 4, 6, 6 plus 3, 9, 9 plus 3, 12, 12 plus 4, 16. And as you can see in this answer also, here output is 16. Okay, so what we have done is, first we have calculated our complete prefix sum array, and then we again iterate in our prefix sum to find our result. Okay, so what will be its time complexity? Its time complexity will be big O of n for first creating the prefix sum and then again iterating in the prefix sum. Okay, and its space complexity will also be big O of n for this prefix sum. Okay, but this is not looking good. Like, do we really need this space? Do we really need to keep the track of all these prefix sums? No. Let me tell you how. Okay, so let's see, we have been given with an array 1, 2, 3, 4, 5, 6, yes, 7. Okay, so let's say instead of making prefix sum as an array, let's make it as an integer. Okay, then an odd sum count and even sum count as well. Okay, prefix sum will be initialized with 0, odd sum will be initialized with 0, even sum count will be initialized with 1, and our result. So what we need to do is, let's update our prefix sum one by one, and don't need to store them all the prefix sums in a vector. Now let's update this by one with this value. Okay, now prefix sum is an odd value, right? So we will check even sum count and add it in our result, and increment odd sum count by 1. Now again update our prefix sum 1 plus 2 3. Okay, now it is an odd value, so we will add our even sum count and increment this by 1. Okay, now again update our prefix sum 3 plus 3 6, even value, then odd sum count, update even sum count by 1. 6 plus 4 10, even value, then add odd sum count and increment it by 1. 10 plus 5 15, odd value, add even sum count and increment odd by 1, it will become 3. 15 plus 6 21, odd value, add even sum count and increment it by 1. 21 plus 7 28, even value, add odd count, update it by 1. Okay, now let's again add it. 1 plus 1 2 2 4 6 6 plus 3 9 12 and 16. Oh, again we are able to get this answer even if we have created our prefix sum as an integer. And see, here we have saved our one iteration of time complexity as well, because we are just iterating in our array and calculating our prefix sum and updating our result and odd and even sum count in a single iteration only. So our time complexity will become big O of n, and space complexity now become big O of 1, as we are not using any extra space. Okay, now let's try code this. So what we need to do, we first store this its size in an n, and initialize our result with 0, and initialize prefix sum with 0, even sum count with 1, and odd sum count with 0. Now let's start iterating in the array I is less than n, I plus plus. Let's update our prefix sum with array of I, and if prefix sum is odd, so what we need to do is we need to add the even sum count in our result, even sum count in our result, and update the odd sum count. Okay, else what we need to do, if it is an even number, then what we will do, we will update our result with odd sum count and update even sum count, right? And as the answer can be very large, so we need to do a modulo 1e9 by plus 7. So we will simply do its modulo. Okay, now after this we will simply return it. Let's try run this. Yeah, it's working fine. Let's try submitting it. Yeah, it's working fine. So yeah, that's all for this question. I hope you get it, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.